The celestial sphere is a mental visualization for describing the location of things in the sky or for describing the separation between things in the sky. Before I talk more about the celestial sphere, as a warm up exercise, I want to talk about the notion of latitude and longitude on Earth and approach the question, what is latitude and longitude really? So, latitude and longitude are two pieces of information or two numbers. And if you give me the latitude and longitude of your location, I have all the information I need to find wherever you are on the surface of the Earth. Latitude will tell me how far above or below the equator you are, and longitude will tell me how far to the east or to the west of the Greenwich Observatory in London that you are. Now, if I'm talking about how far above or below the equator you are, the equator is a fairly reasonable and natural reference for determining locations on the Earth. In terms of longitude, how far to the east or to the west of London are you? Well, there's nothing fundamentally special about the Greenwich Observatory. We could just as well use any other location for a reference for longitude, like Paris or Cape Town or Riyadh. We just happen to choose Greenwich Observatory in London as our reference for longitude. Now, when I'm talking about your location on the Earth, I am assuming that the Earth is a nice smooth globe, which is a very good approximation, and I'm ignoring differences in elevation or altitude. So I'm not really worrying about, are you on the second floor of a building or the fifth floor of a building or something else. Fundamentally, I claim that latitude and longitude are just measures of angles. Now, throughout this course, in my opinion, it is important to me that I want you to believe what I say, not because I said so, but I want you to believe what I say because the things I say should be natural to you. If you don't understand something the first day, that's just fine, but I want you to believe what I'm telling you because it is reasonable and makes sense to you. So, what is the defense for my claim that fundamentally latitude and longitude are nothing but a measure of angles? Let's first spend some time talking about latitude. So, latitude tells us, we said, how far above or below the equator we are. So let's look at the Earth from a side view. And for this discussion, I am going to claim that I'm going to be somewhere right on the edge of the Earth here between the equator and the North Pole, somewhere in the Northern Hemisphere. If you don't really want to be here, maybe you want to be in Florida, well, you could picture we would spin this globe until Florida lies right along this edge. Just restricting our location to lie along this edge of the Earth right here from our perspective will make this discussion a little bit easier. So let's take one line and let's stretch that line from the center of the Earth to the equator. Okay, there I go. Here's the center of the Earth. Here's the equator. Let's take a second line and let's stretch this line from the center of the Earth to the North Pole. So here's the second line from the center of the Earth to the North Pole. And notice that these two lines make a right angle with each other. In other words, these two lines make an angle of 90 degrees with respect to each other. Now, let's presume that there is a boat located right here. We said we are only assuming that we are restricting ourselves to lying right here on the edge of the Earth from the perspective of this picture. And as I said before, if you really want to be somewhere like in Florida or Georgia or wherever, just spin the Earth until that location is on the edge from this perspective. So this boat right now is going to, if I draw a line from the center of the Earth to the location of that boat, this new line would be 30 degrees above the equator, or equivalently, I could say this line would be 60 degrees below the North Pole, because this is a 30-degree angle, and this would have to be a 60-degree angle, because the equator to the North Pole is, we said on the previous slide, 90 degrees. So convince yourself that the angle from a line from the center of the Earth to the equator, which is this line drawn in green here, And the line from the center of the Earth to any location in the northern hemisphere will always be something between 0 and 90 degrees. So this would be a very small angle. A line from the center of the Earth to right here might just be 2 degrees above the equator. A line from the center of the Earth up to here might be 45 degrees above the equator. A line from the center of the Earth to way up here might be 88 degrees above the equator. But this line is always going to be something between 0 and 90 degrees. If the equator is at 0, said to be at 0 degrees, sweeping up to locations in the northern hemisphere will give positive angles. Then sweeping the opposite direction, sweeping down towards locations in the southern hemisphere will give negative angles. However, instead of talking about angles being positive or negative numbers, we just say 30 degrees north for locations in the northern hemisphere or 30 degrees south for locations in the southern hemisphere, rather than saying positive 30 or negative 30 degrees. Latitude tells us how far above or below the equator that we are in terms of an angle, and by a very similar spirit, longitude will tell us how far to the east or to the west we are of the Greenwich Observatory in London in terms of an angle as well. So what I'm going to do is I'm going to begin by drawing a line from the center of the Earth right to the Greenwich Observatory in London. Now, before I go on, I want to point something out. If we look at this picture and we said, okay, let's pretend there is a boat located right here in the Atlantic Ocean, and we thought about it and reasoned that this boat is a 30-degree angle above the equator. But what if you don't want to be on a boat in the middle of the ocean? What if you want to be in Florida or California? And we said you are allowed to rotate the Earth until Florida or California is right at this location. Essentially, what we were saying is you're allowed to move to the east or to the west for free, as long as you don't move to the north or the south, you're not changing your latitude. Similarly, I'm going to say that you're allowed to move now, when we talk about longitude, to the north or to the south. That is going to be for free. As long as you don't move to the east or to the west, you're okay. So maybe I don't want to be in London. Maybe I want to go south to France, or maybe I want to go further south into North Africa, or maybe I want to go really far north and up in the Arctic Ocean. That is fine. As long as I don't move to the east or the west, it will not affect what my longitude is. So we begin at 0 degrees longitude, and then we will move east and we will sweep around and until we arrive at the location on the Earth that we are interested in. So let's say we want to go to Kamchatka, Russia to see where season 3 of Stranger Things ended. Well, Kamchatka, Russia is way over here. It's this peninsula that is pretty awesome for all the volcanism there. And to sweep from London, England to Kamchatka, Russia, I would have to sweep 160 degrees to the east. So I would say Kamchatka, Russia is located at 160 degrees east of the Greenwich Observatory in London. Now, very similar to latitude, we said you could sweep from 0 to 90 degrees upward or 0 to negative 90 degrees downward when we talked about latitude. But instead of going 0 to plus 90 or 0 to minus 90, we called that 0 to 90 north or 0 to 90 south. Similar for longitude, we're not going to sweep from 0 to 360 degrees. Instead, what we're going to do is we're going to ask, are we sweeping to the east or are we sweeping to the west? And when you end up at exactly the opposite side of the Earth, it doesn't matter if you swept to the east or to the west, you're at the same location. So if instead of going to Kamchatka, Russia, we wanted to go to Cleveland, Ohio, we could say that we begin at the Greenwich Observatory in London, and we will have to sweep around 82 degrees to the west. And at that point, we are at the same longitude as Cleveland, Ohio. And again, remember, we are allowed to move to the north or to the south for free. So we begin at London, we sweep around to 82 west, and then we go a little bit south and arrive at Cleveland. So Fundamentally, latitude and longitude are nothing but measures of angles, but instead of going 0 to 360, we add this E for east or this W for west, but it is ultimately the exact same thing. The reason we talked about the notion of latitude and longitude fairly in depth is because the celestial sphere is very similar in spirit to the concept of latitude and longitude on Earth. We said that every location on Earth can be entirely and completely described with two pieces of information. No matter where you are on the Earth, if you give me your latitude and your longitude, that is enough information for me to find you. The celestial sphere is very similar. Let's pretend that every star in the sky is pinned to the inside of a giant globe, and the Earth is going to be located at the center of this giant globe. Now, the Earth, we know, does rotate. For the moment, let's pretend the Earth is not rotating and the stars are not moving in anything. So nothing in this picture is going to be moving for the purpose of this discussion. In this model, we are pretending that every star is the same distance from the Earth. This is not the way nature actually works. We know that some objects are closer to us, others are further away, but this model is still useful for astronomy, and we'll see in Chapter 4, during some early days when astronomy was becoming more of a formal science, this was the picture that some people actually thought nature looked like. So, you could look at this picture, and if you think about it, you could convince yourself that at every star in the universe will be directly overhead of some location on the Earth. If I am right by the North Pole, I might have the North Star being directly overhead of me. If I am somewhere in India, I might have this star right here being directly overhead of me. This star over here might be directly overhead of me if I am somewhere in, let's say, Australia. But every star on the celestial sphere is going to be directly overhead of one location on the Earth. With that thought in mind, I could kind of think of the location of every star in the universe being described with some type of latitude and longitude. Basically, where would I have to go on the Earth so that that star is directly overhead of me? Now, the celestial sphere is useful to describe locations on the sky. Similar to locations on the Earth, every location on the sky could be specified with two numbers. Latitude and longitude are not useful here because in the real world, the Earth actually does rotate. So the star might be overhead of you for a moment, but as the Earth spins, it's not going to be overhead of you sometime later. So instead, numbers called right ascension and declination are used, but we're not really going to worry so much about that. The important thing I want you to have is a mental picture of what is the celestial sphere. So think about the celestial sphere, this picture here. Look at the star map and think about it, pause the video if you need. Where on the Earth would you need to go if you were to step outside and see this picture of the location of stars in the sky? So if you saw the stars in the sky here, the dotted line is the horizon, where on Earth would you be? Pause the video, think about it. And the location that you would be is you would be right by the North Pole, because if I look at this, the North Star is directly overhead of me, so I would have to be at the North Pole. Now, technically, we said the North Star is not perfectly above the North Pole. It's slightly shifted away, but it's close enough for what we're talking about in this course. So all the stars around us that we see in the night sky are orbiting the center of our galaxy, and the stars are moving in space. But we learned back in Chapter 1 that space is very big and the stars are very far away. Compared to timescales of days or years, the stars could effectively be treated as perfectly stationary on the celestial sphere. It is true that the stars move, but over the course of a human lifetime, the positions of the stars in the sky, the constellations, will not change in any perceivable way to human eyes. So watch the video Cosmos Star Formation with Carl Sagan up next in the playlist. This clip of a video is not actually about star formation, but it talks about the positions of stars from different perspectives in space and time, and it presents this in amazing 80s animation and synthwave music. And then I'll see you in the next video.